All right, we are live. So, hello everybody. My name is Jenna Dodge and I am here with Celeste and her husband Derek. And we are here today to talk about EMFs and what they are and why we should care about them, and 5G and how that affects our health. So Derek is an electrical engineer that specializes in wireless technology, and Celeste is one of our team members. She's a homeopath and super knowledgeable about all things health. And today we're going to be talking about EMFs. So first, tell me guys, what are EMFs?
Well, EMFs stand for electromagnetic frequencies. And basically, you can think of EMFs as just about everything that comes from the sun. Light is the most common EMF that we deal with on a regular basis. But as you go up above light, you get to ultraviolet, you get UV, and as you go below light, you get to what we use today as radio waves. So as that frequency of oscillation goes down and down, you use those as radio waves. And at the low end, we often use radio waves like your AM and FM radio stations. And then at higher frequencies, we'll use our cell phones. And one of the things that we're doing now is doing more and more with radio frequencies. And radio frequencies are really a byproduct of electricity as it moves around things. So even though we talk about EMFs as they directly associate with radio waves, it's also useful to keep in mind that EMFs can come from basically anything that uses electricity. And in fact, one very important source of very low frequency EMFs are power lines. And the electrical lines that come into everything, they have some EMF radiations, but at a very different kind of frequency range. It would almost be like, it's a much lower level of EMF that a lot of our cell phones and others can't see because it's too low. Just like we can't see radio waves themselves because they're not within our focus point of EMFs that we call light.
Gotcha. Okay, so when we talk about EMFs, yeah, so it sounds like they're everywhere at different levels of frequency and energy. So what are some of the health consequences of just EMFs in general? Are there health consequences?
Well, there's a lot of discussion about this, and actually a lot depends on individual people's susceptibility. There's a difference in there's a lot of research out there that's been done, and a lot of it is kind of all over the map. But there are two main effects that people look at: the thermal effects, which are the effects of heating that actually happen. One of the frequencies of EMFs that are used is what's used in your microwave oven. So the frequency in a microwave is specifically tuned to heat water, which is why it works. But that heating effect can be more or less, diffused in different applications and different frequencies of radio waves. So you have those thermal effects that are a little more defined and a little more understood as far as the mechanism goes. And then you have the non-thermal effects, which are really, still kind of speculated on and not really understood real well. But those, we can talk about those a little more later, but those are the kinds of things that actually could disrupt cellular mechanisms and functioning, and kind of impact cellular processes over time.
Gotcha. Okay, that makes sense. So then when we're talking about 5G, since that's kind of in the news, we know the 5G is being rolled out in Bozeman, where I live. March 4th was, not national, but like a countywide 5G day here. They kind of celebrated it. So what is the difference between 5G? What is 5G and how does it compare to quote unquote regular EMFs?
Well, I think the most important thing to understand about 5G is that they're trying to extend 4G. It's the next evolution of wireless technology. And we've sort of started to get used to 4G. We're used to seeing the 4G icon on our phones. We're used to seeing the LTE icon on our phones. And LTE standard for long-term evolution, which was a pathway for wireless to just keep getting better. And all 5G is really designed to do is say, let's make sure that our wireless capability and our network and everything else has room for all kinds of new innovation in it. And the other thing to keep in mind is that wireless has become super popular and super valuable. And when we're talking about all of these EMFs or these radio frequencies, those applications, those frequencies are something that is regulated today, and they're allocated in spectrum. So different types of frequencies and different frequencies have different uses. They're regulated and given in spectrum. Well, nowadays spectrum is almost like a different kind of real estate, where companies purchase spectrum from the government and are given a regulated use within that. And what 5G says is that we want to, in order to do more things with wireless, we want more real estate to build new wireless applications. And that means that one of the most significant differences in 5G from what we currently do is the new spectrum opportunities that are opening up. This is one extra feature of 5G. So 5G is going to take all your 4G stuff and add an extra layer on it and kind of expand the feature set. One of the things that we're talking about here specifically when it comes to EMFs is the fact that 5G is going to be using new EMF frequencies that weren't involved before in 4G. So 4G, everything that we do in 4G is pretty much done between a little less than 1 gigahertz and up to about 3 gigahertz. So it's this very, fairly narrow range of spectrum. And by the way, we should also mention what we're using right now, which is wireless LAN or Wi-Fi. And that uses spectrum in 2 gigahertz to 6 gigahertz. So you have kind of this whole range between 1 and 6 gigahertz that most of our high data communications and everyday communications is happening on. Well, 5G is trying to open up new bands of spectrum in very different places. In particular, the bands in the 20 to 40 gigahertz range are being opened up. So this is 10 times the frequency rate that compared to the current cellular frequencies. And so now we'll be able to build wireless applications at these much higher data rates. I'm sorry, higher frequency rates, which implies, because of the physics with it, potentially much higher data rates as well. So these higher frequencies in what we call the millimeter wave bands are very different kind of in the physics of it, require different technology, real challenges for us as engineers to try to figure out how to make them work. And the networks are going to have to be implemented much differently because of these much higher frequencies that are 10 times as high as your current cell phone rates. But when we say 5G, we shouldn't just assume, oh, 5G means that you're doing this high frequency stuff. No, that's just the new cool part of 5G. Really, 5G is going to take all of your 4G stuff and just upgrade it so that everything, wherever you are, can talk, and new applications and new capabilities can be developed.
Gotcha. Okay. So then, are there any potential health consequences to opening up, those newer frequencies, and what might we expect there?
Well, I think we could talk about. Well, let me talk about some of the engineering aspects of putting a system in at those higher frequencies, and then maybe let Celeste talk a little bit about the health implications and what are the things that we're trying to discover because of that. At the thing with the higher frequencies is they actually don't naturally transmit as far. The energy falls off more quickly. It tends to get absorbed on more things, and it tends to bounce off more things. So it's harder to get that energy, all the way across town like we're used to with our current cell phone networks. That microwave frequency, so in order to actually get a good link, especially these super high data links that they want to have, you need to take the energy, you need to bring your base stations closer to your cell phone or your laptop or whatever. Your base stations need to get closer, and typically you need to focus your energy in the beam rather than just kind of radiating out like a light bulb. They're going to need to focus it more like a flashlight. And so they can get it where they want to and not just send it everywhere. So 5G has to, at the millimeter wave frequencies, has to be a lot more careful with the microwave energy than it did with the lower frequency energy, which it could just sort of broadcast. Now they have to be a lot more careful with that. Move it closer, beam it a little bit more tightly, maybe have some higher energy outputs in some cases, but really managing that energy is going to be much more of a challenging thing. This is one of the things that I think is going to be a little bit tricky as 5G starts to roll out. So in the first clip case, your 5G in Bozeman is probably mostly these low frequencies. When we have 5G and it goes out here where I am out in the suburbs of Dallas, even though Dallas was one of the original 5G suburbs, we don't have any high frequency 5G. High frequency 5G is special networks that are being located up and putting those together. And in order for this to get those high frequency 5G things, it's going to require special implementations, and that's going to have to get moved out. We're concerned as engineers that as these new networks and new devices and things roll out, there's a lot of flexibility there, including some ways to implement those networks in potentially unhealthy ways, where those base stations are put a little bit too close and where those power levels and settings are a little bit too high. And those higher frequencies also might have health effects that we're still discovering right now. And maybe Celeste is better to talk about that.
Yeah, well, so, again, getting back to like the different kinds of effects that electromagnetic frequencies have in general, the higher frequencies, like Derek said, they're not going to be installed and put out in most areas. They're going to focus on,
at least not for a while.
For a while, yeah, because there's so much involved in getting them set up. So they're going to be in like the downtown areas, the high population density, industrial kinds of commercial areas, at least initially. But because of the more ubiquitous nature of these high frequency base stations, they have to be put closer to where the cell phones are, where the communications are. And so they become more ubiquitous, and they're because of the higher output that they put out, one, because they've got higher data that they're transmitting, and also because they need to push that signal out stronger to help boost it, because it falls off faster. The energy output at those data stations is much higher, and so when you get closer to it, you get more of those thermal effects that that the industry understands more strongly at a closer range. So that's something to keep in mind. And then also, because of the ubiquity of it, and because it's all over the place, and because people are going to be using it more and using it more extensively with those high data rates going back and forth, then any non-thermal effects that we still don't quite understand might be accentuated and propagated on an ongoing basis, just kind of as part of our lives. So some of those things, there's been some studies that have demonstrated that one of the possible mechanisms for interaction in the cells is disrupting the calcium pathways in the cell membranes, calcium transport back and forth in the cells, which is really super important in cell signaling and hormone signaling and a lot of other processes. So it contributes to oxidative stress in the cell. It can contribute to cellular DNA damage. It can cause a tendency for greater apoptosis, which is cell death. These are some of the cellular level implications that could happen because of higher exposure to these electromagnetic frequencies at greater intensity and more consistently. And some of the concerns that are shown in other studies over the long term, and depending on susceptibility and things, we have potentials for developing cancers. EMFs in general have been designated as potential, cancer risks. They are not sure, but there's a possibility. Changes in mood and concentration, thyroid issues, sleep difficulties, fertility problems, all these things are a factor of EMF frequencies in general and can possibly be accentuated with that greater exposure that we have with 5G. And again, a lot depends on how the 5G is installed, where you are in relation to that, what your usage is of the 5G signaling, and again, always comes down to susceptibility. So where you're at, physically in your body, and how how your body responds to the pressures and imbalances that might come from EMFs.
Gotcha. Okay. Yeah, and that's so much information. I took a bunch of notes. I have to take notes when I'm learning things so I remember them. So thank you for that. That was super informative. And I'm pretty sure we could keep talking all day long, but we have a presentation in our group, in this group that you're in. And if we do share this on our timelines, then you'll have to ask us for which group. And it's called Biohacking Against EMF. And it's all about how we can potentially protect ourselves against some of those things you mentioned. I heard the word oxidative stress in there. So obviously we're perking up and paying attention to that. As well as some of the other things, potential health consequences of EMFs. And, I think we're on the same page, you and I. It's always best to protect ourselves as best as we can, no matter what, the environmental thing might be. So that presentation is tomorrow, Thursday, March 26th at 8:30 your time, Central Time. So that's 9:30 Eastern. And what is that, 6:30 on the West Coast? So do you have anything more to add, or do we just want to have people join us for tomorrow's presentation and learn all about the things we can do to protect ourselves there?
Yeah, I mean, the big thing is that, it's not about scare tactics. It's not about, panic and worry and, put your tinfoil hat on and, shut yourself up in a corner. But it's about being aware of, what potential, our world is changing a lot. And, with the modern technologies and things that are being implemented, they're just, this is an experiment in the human race. And so, while we're trying to go about these, and our engineers are trying to go about these developments as, safely and mindfully as we can, there's still good reason to be proactive ourselves and to help protect, ourselves and sustain, the health of our bodies as best as we can. And I think we've got some great tools for doing that. So I'm excited to find out more about that.
Thanks, Jenna. This has been fun.
Yeah, thank you so much for coming on. I definitely learned a lot. I hope everybody watching did as well. Feel free to leave questions for Derek below and we'll have Celeste pass those along. Or for Celeste, obviously she knows all about the health stuff. So yeah, we will talk to you guys later. Thanks again and have a good afternoon, you guys.
Thanks, Jenna.